Sorry about that, guys. I ran out of time in my previous video, so I have to finish inductance in part 2. This graph here, it's measuring the voltage across this resistor. These little components here, these are grounds, and if you imagine the Earth as the ground, which it is, so if you were to take a battery or an inductor or a capacitor or whatever, and if you were going to put all of the charge in that component into the Earth, well, there'd be almost no change in the charge of Earth. But there would be a lot of change in the charge of the battery or the inductor or the capacitor. And in this schematic, that's really what it's for. So if I were to flip the switch here to this 9-volt rail, basically that means that from somewhere we've got 9 volts coming in. So if I were to flip that switch there, in this graph you can see the voltage across this resistor is going up in a curved way as this magnetic field is created around the inductor. The voltage slowly increases across the resistor. When I flip the switch back to ground, you can see these arrows, the current's still going in the same way, from ground to ground, and the voltage slowly drops exponentially across the resistor. Now that we've pretty much finished inductors and capacitors, so I'm just going to show you a quick application of the two of them. Now this is used in a radio when you need to have your whole circuit timed to a specific frequency. How do you do that? Well, you can use a capacitor and an inductor together. When the capacitor is charged, and then it releases its charge into the inductor, and then that inductor becomes charged, and then the capacitor becomes discharged, but the inductor is still charged, and pushes the electricity charge to the capacitor in the opposite direction, and then the whole thing repeats itself in the opposite way. I'm going to show you that real quick. This switch here is 2 switches in one, so we're just going to switch this capacitor from either being charged by this battery to being discharged and recharged by this conductor. And then the second switch over here, which I'll use later, I'll just show you what happens when you add a resistor to your circuit, because it can only be in one way. Okay, so the capacitor is charged. This graph is showing that we have some charge on the battery, and then this graph is showing that there's no current going across the inductor. So if I switch it to the other way, suddenly there's slowly current going up on the inductor, and as the capacitor discharges, but then the current starts going down in the opposite way as the capacitor recharges and discharges in the opposite direction. Maybe it'd be more helpful, instead of looking at the graph, to look at the arrows and the charge indicators on the simulation. The arrows go in one direction as the charge flips in one direction, and then both of them kind of flip around, and the whole circuit repeats itself. Now if you were to add a resistor into this whole equation, well, right now this circuit is very, very efficient because there's really no energy loss from either the inductor or the capacitor or the conductive wire. So if I were to add a resistor, which suddenly converts energy from electrical to heat and takes it out of our system, you can see that these waves here, the current, even though it's still oscillating, each time it approaches zero, more and more. And each time the charge gets closer and closer to zero. And eventually it's going to reach zero because all of the energy is going to be dissipated by this resistor. Yeah, that's really how it works. And then the radios use this concept to time the whole circuit in the radio. And I'm not going to explain exactly how radios work, but they need to be set to a certain frequency so that they can receive the radio signals. I'll leave it at that. Yeah, so that completes my lesson. If you want to check out the program I'm using to simulate these circuits, it's called Yenka. That's how you spell it up there. it's pretty cool. I think it's really cool because you can make circuits and play with electricity without actually having to go to the store and buy your components. I'll get you to use it later when you do your final project for electricity. I will get you to make some circuits and show me what you know. So you might as well play around with it early. It's free as long as you use it at home and not at school. But you have to be doing schoolwork at school anyways, so whatever, doesn't matter. Awesome. So yeah, until next time, happy learning, and goodbye.